Hi, this is Wendy Lightheart, and today we're going to be looking at how to add and subtract rational expressions that have uncommon denominators. So remember that when we add or subtract fractions that do not have the same denominator, the first thing we need to do is find the least common denominator. So first we're just going to go through the steps on how to find the least common denominator, or LCD, of two rational expressions. The first step is to factor each denominator completely. The reason for this is that we are going to build the least common denominator using those factors. The second step is to begin building the least common denominator by taking all the factors of the first denominator, and next we'll take all the factors of the second denominator that we don't already have from the factors of the first denominator. Then we multiply all of these factors together, and this product will be the least common denominator. So let's look at an example. Here we want to find the least common denominator of these two rational expressions. So remember that your first job is to factor each of the denominators completely. So when we do these factoring problems, you might want to pause the video just to practice your factoring skills. So if you factor the first denominator, you should get factors of x times x plus 1, and that is factored completely. And then looking at the second denominator, that will factor into x minus 8 times x plus 1. So both denominators are factored completely. So our next step is to take all the factors from the first denominator, which is x and x plus 1, and then take only the factors of the second denominator that we don't already have. So notice we already have a factor of x plus 1, so we only need the factor x minus 8 from the second denominator. And then we multiply these factors together, and that is our least common denominator. So the least common denominator of these two rational expressions is x times x plus 1 times x minus 8. Okay, now let's talk about adding and subtracting fractions that do not have the same denominator. We're going to start off with some simple fractions, and then we'll move on to rational expressions, because really it involves the same technique. So the first thing we need to do is we need to find the least common denominator. So we'll do this using the steps that we showed previously, which is to take all the factors of the first denominator, which is 2 and 7, and then take only the 5 from the second denominator, since we already have a factor of 2 from the 14. Multiply those three factors together, and we get 70. So 70 is the least common denominator of these two fractions. So now we want to rewrite these fractions into equivalent fractions that have denominators of 70. So to do that, we multiply both the numerator and denominator of each of these fractions by whatever is needed to build its denominator up to the least common denominator. So what would we have to multiply 14 by to get 70? The answer is 5, so we'd multiply that fraction, both the numerator and the denominator, by 5. What would we need to multiply 10 by to get 70? The answer is 7, so we'd multiply both its numerator and denominator by 7 to build its denominator up to the least common denominator of 70. So now we perform that multiplication, which gives us two new equivalent fractions of 45 over 70 and 21 over 70. Now we're ready to perform the addition, since the denominators are now common. To do that, we simply add the numerators. So if we add the numerators, that will give us 66, and we'll put that sum over the common denominator of 70. And then we always want to simplify our fractions if possible, so this one can be reduced down to 33/35. So remember, the reason why we went over the steps using these simple fractions is that we're actually going to add and subtract rational expressions the same way. So the first thing we want to do, again, is to find the least common denominator. And to do that, we start out by factoring each of the denominators completely. So again, if you want to pause the video for a second and try to factor these yourself, go ahead. So when you factor the first denominator, you should come up with factors of x and 2x plus 5. So again, that's by finding a greatest common factor of x that you can pull out. And then that is factored completely. And the second denominator, you should have gotten factors of 2x plus 5 and x plus 2. Now we're ready to build the least common denominator by taking all the factors of the first denominator, so the factor x and the factor 2x plus 5. And then from the second denominator, we already have the 2x plus 5 factor, so we'll only take x plus 2 from that denominator. And we multiply those three factors together, and that is going to be our least common denominator. So the next thing we need to do is to build each of these denominators up to the least common denominator. So we need to think about what factors are missing. What would I have to multiply the first denominator by to get the least common denominator? Well, notice that the only factor that's missing is the x plus 2. So we'll multiply that fraction, top and bottom, numerator and denominator, by x plus 2. Then if you look at the second denominator, the only factor that's missing there is a factor of x. So we'll multiply the numerator and denominator of that fraction by x. So if we perform that multiplication, we will have the least common denominator. So let's go ahead and do that multiplication. Now keep in mind that eventually we're going to want to simplify, and to simplify a rational expression, you're going to want both the numerator and denominator factored. So we're going to leave the least common denominator in factored form, but to perform addition between the numerators, we're going to have to actually perform the multiplication between numerators first, and then we can add the two numerators together. So to multiply x plus 2 times 5, that requires distribution. So we distribute 5 through the factor x plus 2, and you should get 5x plus 10. And then the same thing for x plus 3 times x. We would distribute the x through the binomial of x plus 3, which will give us x squared plus 3x. Now we are ready to add the numerators together and put that sum over the least common denominator. So again, keep that denominator in factored form. So if you add the numerators, we'll just be combining like terms since it's addition. So that will give us x squared plus 8x plus 10. Then of course we would always reduce the answer if possible. However, notice that the numerator will not factor. So since it does not factor and it does not match any of the factors in the numerator or the denominator, then we won't be able to cancel any common factors, so this is our final answer. And most of the time it's okay to keep the denominator in factored form, but if you prefer, you can also multiply that out, and that will be also a correct answer. So just remember that adding and subtracting rational expressions is really the same process as adding and subtracting simple fractions. So if you have that process down for adding simple fractions together or subtracting simple fractions together, just remember that it's the same steps to add or subtract rational expressions. Okay, we're done for today, and we will see you later. Thanks. Bye-bye.